How's it going, everyone? Welcome. Javier Gonzalez here, and I was going to continue to exploring working with state, which is the Model 2 in React. This is a course made by Josh Comer, software engineer that has previously worked at Khan Academy and Gatsby. And the idea of this is, well, to understand is how do we get here? And not only by exploring is this particular course, but also to understand is the story behind this to make sense of how we right now as JavaScript developers, what are the things that we need to understand in order to now provide the expected value for the companies and understand what is the end goal that we are doing when we get hired for any of these companies, which is creating is an experience. Okay, so is at least the goal, but it turns out that this is not the end goal because creating experience or creating products that people love to use and so on and so forth is something that is never is a straight line. Similar to acquiring knowledge or similar to understand the things, the reality of things. It's not a straight line. In fact, is anything that is not in a straight line. So it's anything else except that a straight line. So because of that, and well, this series of video act as a testimonial of that fact, which is, hey, despite that we have seen several of these courses, whether it is Model 1 from React or from CSS or from JavaScript, right? It's up to you at the end of the day to understand how all of these things works. What is the connection behind the scenes and how they work, so you can actually be effective with this. So there is true on that. So because of that, and since right now we're looking at the Model 2, which is working with state, okay, I want to go on in here, and right now I would like to move to the next model, which is the forms versus states, as well as dealing with complex states, dynamic key generation, and some key gotchas here, because in the Model 0 we talk about is the React. What is React? Who makes the React? A little bit of history of React, which was developed by Facebook to solve a specific problem that they have in the UI when it comes to sync a state with different UI. And also is that as we now look at how can we create our own React, which is just creating as an element and returning that as an object, what you can do with React, which is not only is working with the web, but also for React Native, for example, for the mobile development. And this is important because this UIs or this UI elements that React allows us to create, in the case of the React Native, in the case of that, you have to now create some wrappers around that underlying API to work with. Okay, so in other words, it requires you to not only to have a deep understanding of how React actually works, but also is the JavaScript, which is what the language in which is React built upon that. And understanding is that how this language actually works. This is one, and also is that how you can create now a particular interface that now allows you to communicate with that directive, and what are the patterns and the protocols and the standards that they follow in order to use that. So, for example, in the React Native, because React allow you to in the web define all of this user interface, but React Native allows you to interact with all of this user interface. For example, Swift UI or the Kotlin designs is for them. But if you need is some other features that are not part of the UI, this is now when React at the end of the day is not meant to. They didn't create that for that. It was created by Facebook to solve the Facebook problems, and Facebook problem. I don't think they have things like activity or Apple Pay, React Native, which is something that we can discuss about that later on. You know, Apple Pay, React Native payment. Important notice: this project is no longer maintained. The good news is that the landscape of payment of React Native has massively changed in the last few years. There is still room for this repo to evolve, in which I'll detail below, but first, I would like to direct your attention to well-funded and well-maintained alternative that will give you fewer gray hairs. Stripe has released the official React Native SDK support Apple Pay that has a huge team of pay engineers behind that. It also have been included in the Expo management environment. Look at this, which means it's work on Expo Go. Huge achievement. For a bug-free experience and easy integration, I strongly recommend you use Stripe React Native on new projects. Okay. So it's now a Stripe that say, hey, because we are heavily using is React Native. Stripe React Native. Because we are using heavily React Native, okay, we can now that we provide a seamless integration with Apple Pay. Payment methods, accepting more payment methods help your business expanding global reach and improve checkout conversions. Scale ready, the SDK automatically provides native 3D secure authentication if need to comply with strong customer authentication. It provides now a native UI and a payment sheets. Learn how to integrate payment sheets, our new pre-built payment UI for mobile apps. Payment sheet lets you accept cards, Apple Pay, Google Pay, and much more out of the box, and also supports saving and reusing payment methods. Okay, but I think that this is like a specific, it's a specific widget for them. Accept a payment, securely accept payments online. Ask about this page, copy for LLM. Redirect your customer to Stripe checkout. Show page success, and there you go. But again, it's now they have their own built-in checkout process. The web, how it's gonna look like in the iOS, exactly how it's gonna look in the Android, which I think remains the same. In React Native, and plugins. Interesting. So you have now pay or pay with that link and so on and so forth. But again, interesting. So now you can have access to that, to the Apple Wallet or Apple Pay. Okay, one of them is the Apple Pay and the other is the Apple Wallet. Okay, and the other is the Apple Wallet. And the other is the Apple Wallet. In Object C. But in any case, this goes beyond again the scope of this discussion. This is part of my job. But as we look at the other environments that we can run React to represent this user interface on each one of those places, the web, the mobile, or the WebLG. We also look at how can we create this user interface in this React-like way. Returning us is a object that describe how the UI will look like at that particular state. That's what they mentioned here as the React is a this declarative UI. So we describe is the GSX syntax, GSX expressions, the difference between the HTMLs, what is this GSX. This GSX is compiled to JavaScript that actually is ultimately what the browser is going to execute. And also for example, white space gotcha. Okay. And when it comes to now describe the way of how we define components in this particular way with the HTML, CSS, and JavaScript all in one single file. We look at how can we create that? What is the syntax form? What is the properties that this component style looks like in React? What you have is the props and the children and how these are now injected at runtime so you can have access to, all right? Which is quite similar to the value of this when you pass now and call that with a bind and call. But unlike them, these properties are well known as fixed, but this context may change. So that's a subtle difference here. And then how can we use is things like the fragment. So what the fragment is, what is the default settings in our project, how is the application structure. So you have now the index, which is like the configuration file, the app, which is the home base of the entire applications, and then the models, where you can define and describe all of these different UI elements or components, right? Also, we saw how can we define this list of elements, how can we iterate through collections, and how now the iteration is unlike other template engines. So GSX is quite interesting because now we reuse the JavaScript logic for that. When it comes to rendering collections of elements, why we need to put a key, what is a key, what it represents is a key in each one of those components, and how can we now is define is a range, right? To instead of receiving is a collection, is receiving is a number, and from there recreate that particular range. So for example, hey, I want to create from 0 to 10 or from 20 to 30, all right? I want to make you to create that in a particular with a given step. So in other words, let's say I want only the odd numbers from 20 to 30 with a step of 2. So it's going to go from 20, 32, 34, so on and so forth. And this is a great thing with range functions. And how is a side note to say clever code can be harmful because it is easier to confuse other developers, and not only that, it is harder to maintain that code. And when you need to conditionally rendering elements, how we use is the different strategies that we have in JavaScript, or at least in React, such as the if, all right, and the expressions, whether it is the and that acts like an if, whether it is the conditional the ternary operator that act like an if and else, or the hiding and showing elements via CSS, and how can we use as a useful snippet of code to help assistant technologies such as screen readers to look at the text and describe that without actually showing that to the normal users. And also the way of how can we style components here. So because styles here, you can define it can be quite cumbersome and burdensome to go and define that is in an object. Here we can use it in something called CSS model that with tools like Babel, Webpack, which is a model bundler, it say, hey, let me take this CSS code and any of these declaration going to convert that into an object that you can have access, so you can put that reference into your class. So when you do that, behind the scenes, the value assigning here is something that Webpack, this model bundler, say, hey, I'm gonna create this long strings to attach this. Because the idea here is that unlike any other practices and methodologies in CSS like bend, block element modifiers, where it requires that the developers follow these particular rules, it requires discipline for the developers. It is interesting that the community in itself has found out that we as human, we don't work that way. This is not how we resonate. This is not how we respond to stuff, especially when we have to do things just for the sake of discipline, of the performance, right? But if there is a particular goal, or if there is now something that can, in this case, automate that process, we are much likely to respond to that and use it. But this is why we need to understand how all of the things work. This is just model 1, okay? And in model 2, where it's exploring is now how we're gonna work with states by looking at the, in this model is how the browsers, so how can we now bind is an event, or how can we detect events in the browser? How can we now bind its functions to an event? How now React manipulate is it done to do that? And also is how can we now create hooks and like useState? What this useState is all about, which is to keep track elements, all right, or to keep track, or when you have something that change and you want to keep track of that. That is when you use now a state, all right. What the user state does behind the scenes, the internal of what happened here, which is the core loops of that. Well, part of this understanding is the difference between now the props and the state, also working with forms and working with complex states and statement mutations, and how to share state across the application by lifting it up. Okay, so all of this is just themes that we can use in order to explain and provide that. So, because of that, all right, and since here, we first look at how to respond to user actions by understanding is the event handlers, and the event handlers is the way of how now the browsers responds to events. to user events. So the browser here is this little mini, it's like this mini invasive private investigator that track every little thing that you do. And I love this particular snippet because it's actually show you that, right? I do think that this might be is have several. So the way how this works is by showing you, right, in this particular format. So anytime, so it's like dynamically here. It's like pushing all of this into some sort of stack. Might be one of them. So anytime that that an event is triggered, it's gonna be append that into these collections, right? And we can have a lot of them. Can have 400, 500. Look at this. It's all of the event that has been keep track of, right? Similar for this. It's all of the event that is keep tracking of. And look at this. It's huge. The amount of events that may happen here, right, is huge, my friend. Is huge. This is we're now about to reach 1,000 events that has been fired. Whether it's a mouse event, most of the time most events are very expensive. It's because of that, because these functions are continually evaluating any time that and the mouse move. So you have this, you have the button, you have another button. Anytime you input as well something, it is. It's also keep tracking of the meta, right? You should change input to C. So all of this kind of stuff. So the way of how we can add now, or the way how can we respond to user events traditionally is using the event, the query that element, query selector, that element. Once you have that via class or ID, right? But once you have that, then you want to now is subscribe a functions to that particular event that this element has. So this is how you can do in normal JavaScript, all right? And if you want to, for example, now attach that to the HTML element, all right, what you can say is, hey, let me define this function here and then attach that by calling when this event triggers, all right? So for example, like this. So when this event is triggered, hey, please call this function. But this is not what happened in React. In fact, React, by wrapping this each one of those elements into its own React element, right? If you want to respond to user input, instead of passing a function to that, like we do, like we can do in like exactly. If you want to add user interact, if you want to respond to user events, the way to do that is by passing now is a reference to that. All right. Why is this? Because if you pass a reference, React behind the scenes, and if you remember how this is going to be converted, this UI element or HTML element, how it's going to be converted into a React element. In this case is, hey, this is the bottom, which is the tag. This is now the object that is going to have is the type, which is the tag, the bottom, the type, the key, the props that is going to be defined in this way, all right? And also is the children, which is the content in itself, the nested content. So here you're passing now is a reference, because this object that is being created when the button is parsed that into a React element that contains now is this state of your UI, is React that is gonna decide when to call that, you know. So because this is because React is gonna decide when to call it, and I do think that this is quite appealing, quite powerful, because React will go to um, because React will go to decide when to call it, and based on the user specific event. All right, this add event listener here, or in this case, uh, the events that we are passing this function, it is now uh, a it is now a functions reference. So in other words, this is the recommended way to handle events in React, because React behind the scenes it does a couple of things. One of them is the automatic cleanup, and this is important because you want is to at some point is to remove that event listener from that element, right? So by doing that, well, you release the memory from that. So now the browser doesn't have to actually is uh, listen to that. Uh, and the other is that improve performance, because it can now batch several of these event listener to reduce memory consumption. Interesting. And the other is that there is no DOM interactions. So all of this happens uh, is because React is the way is involved in the DOM manipulation, not us. Mm-hmm. So staying within the abstraction, which is the reason why it say that you will have much better time to that. But this is important to understand here, and that is, if you are now with React, this is a particularly abstraction that you live. If you are now in plain HTML and CSS and JavaScript, this is the way how can we respond to user events. And the other is the difference from HTML, okay? Such as how do you pass now parameters, which is something we're gonna see that. Here you're passing is now a functions reference, and now the events are in a camel case. So when you want to pass now arguments to that, the way to do that, instead of passing now a reference, you're gonna pass now is a functions that returns is the function with the arguments. That might be sound quite elaborate and weird to see that, but an example can now articulate that way much more. Because by passing here, you are saying, hey, JavaScript, I'm gonna pass this you a functions reference of this, so you can now decide when to call this function. Because at the end of the day, is React that is handle that is not only the DOM manipulations for us, but also the automatic cleanup and the batching of several of these events listener in a memory to reduce memory consumption. Holy moly. If you're not super comfortable with arrow function, be sure to check the arrow function primer lessons. Some of them say that this is bad for performance. We may have heard for creating an anonymous function like this is bad for performance. And there's a lot of misinformation out there around this topic, and it is frustrating to me because it makes developers worry about things that really don't need to be worried about. To quick summarize, there isn't a measurable performance difference between creating anonymous functions versus name functions. Same thing for arrow functions versus traditional functions. The cost of creating a new function is extremely low, Even low-end devices can create hundreds of thousands of functions in the span of a human blink. React has a built-in event delegation system that is implementing a bunch of optimizations for us. Now there is a kernel of truth to the concerns around function in React. Exactly, because all of this is about is uh, the arrow function, these inline functions. The performance is not for the inline function or for the arrow function. The concerns about performance is that how now React treats that. Now there is a kernel of truth to the concern around functions in React, but React gives us a tool to manage them. It is called useCallback, and we'll learn about in Module 3. Mhm. Okay, but the concern is about is that how Java is the concern is about React handling that inline function. What are you doing behind the scenes with this inline function? hmm And then it makes a lot of sense for us to say, hey React, please don't execute this function unless these things happen. All right. So what about the bind? So there's another way to do that, not fairly common, so on and so forth. So this is the exercise. The useState hook, okay, which is say, hey, by exploring now, how can we keep track stuff here in JavaScript or in React, okay? So something that changed that you want to keep track, that's when we use this particular hook, the useState. And how we can use the useState, what is the anatomy of the useState, and also yeah, what is the anatomy of the useState? How can we use the useState with these curly brackets? All right. Also the naming conventions to describe our hooks, the useState. We have the value, you have the setter functions or the set function, okay, and also the initial value that we can pass to React. So, which is whether it's an initial value, a simple value, all right, or you can pass is now a functions reference. If you pass now a functions reference, you are telling React behind the scenes, hey, I want you to execute this on the initial render only once. Whereas if you, for example, now pass a value or you call a function inside of that useState, all right, React will call this anytime the component is re-rendering. And to understand now this re-rendering stuff, we need to look at the core React loop. So we have seen that when we update a state variable by calling the setter function. Really? We have seen that when we update the state variable by calling the setter function, the UI gets updated. But how does it work exactly? This question cuts straight to the core of React. The library, after all, is literally named for how it reacts to state change. So this is a question we're going to keep coming back to throughout this course, and as we build our mental model, our understanding for how React works. But let's see if that we can start answering. Let's keep working with our counter example. For example, like this, right? So a bit of a review, let's talk about what happens when this component is rendered for the first time. Our counter functions returns a bunch of GSX. That's right. That's right. So our counter functions return now a bunch of GSX. All right. That this GSX is now the elements, which is the React create element, where the tag will be the button, the props will be is the onClick, following by this, okay, which is at the end of the day is an object, and the children will be the value followed by the count. Okay, so when do we have now this? Okay, okay, here's when the magic happens. When this code runs, produce a React element which is a plain JavaScript object. It looks something like this. So this plain JavaScript is now object is the state at which these components are. So you have now the type button, the key, the ref, the props, which is on children here on click, and the children, as well as the owner here, and the store validate false. As we learned in the last model, React elements are essentially describing React elements are essentially descriptions of the UIs we want. That's all. That's what these components is all about. They're just description of the UI we want. This might be a lot of, and this is interesting because when things are cryptic, or when things sound cryptic, it's because the reader, the perceiver of this content is not ready for. It needs some sort of desire, some sort of level of deep to understand what this means. And I truly understand what this declarative UI means. Is because you are defining per component when that is transpiled to JavaScript into this particular function, JavaScript function, right? That when that is executed, is going to produce now this object, which is a way of how can we represent is the UI, the HTML element at that moment. Holy fuck. This particular line of thoughts is crucial when you're going to understand something. And this is part of the logic. This is part of the logic here. This is part of the logic. We're saying in this case that we want a button. Okay, we want a button that contains a property, or that contains is the okay. We have a button. We want a button that contains the value 0 at this time. And we could visualize this JavaScript object as the following HTML snippet. Our React elements, the JavaScript object, is describing this DOM structure. It's describing this DOM structure. React takes that description and it turns into a real thing, and then creates the button DOM and appending to the page. This is what happened on the initial render. I didn't show the onClick handler in this little sketch, but it's very much part of the process. When React creates and inject the button DOM nodes, it attach our handler function. Now let's think about what happened when this button is click. When the button is click, all right, which is when this function is called, the setCount function will be called and will pass a new value. So count will be increment from 0 to 1. Whenever a state variable is updated, it triggers a re-render. Once again, React will call the counter function and this create a brand new React element. So React will call the counter function, okay, that triggers that state updates and create a new React element. And create a new brand React element, a new description of the UI that we want. Okay, so when we now update the state of, when we update a, when we trigger and state update, we are telling React that this is now the new description of the UI that we want. And the new React element described this DOM structure like this. I'm showing here as HTML since it is easy to demonstrate, but really React deals with JavaScript objects that describe this markup. Each render is like taking a snapshot. We generate a description that shows that the UI should look like based on the component props and state, and it is like a photo that captures what things we are like at the moment in time. And so React has two snapshots. It has this and it has this, right? So since React now have these two snapshots as an object, the user clicked the button and on this second snapshot was generated, React now has to figuring out how to update the DOM. Remember, all the DOM manipulations are handled by React. Okay. So we don't have to do that. So we don't have to do that. Mm. Mm-hmm. 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 Okay. 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 Um, but it makes a lot of sense. But it makes a lot of sense. Mm-hmm. But it's because is anytime, okay, so anytime that a state update is triggered, we are telling React, the new, so we're telling the React the new state or the new description of the UI that we want. And this is not only goal for this component that it calls, but it also in this component has more React elements. It will continue to call all of these elements, aka it will continue to create now this description of the UI that we want in a new snapshot, in this new version of the snapshot. Mm-hmm. In this new version of this snapshot. Okay. So this new version of this snapshot, since React is going to, since React is responsible for the DOM manipulation, not us, right? So we don't actually cherry picking is the elements and modify that to actually show something. It's React that is doing this DOM manipulation. It turns out that And it turns out that now that it has this new state or this new snapshot of the UI that we want, okay, uh, it's gonna now run a comparison. It's gonna run like the spot the difference here via the reconciliation algorithm using fancy optimized algorithms to figuring out what has changed between these new descriptions of the UI, these new objects here. And once that is solved, okay, once React has solved the puzzle and work out what's different, it will need to commit exact. So once React has figured out or has resolved, once React has solved the puzzle and work out what's different, it will need to commit this change. Exactly. It will need to commit this change. It is time for then React to commit this change with surgical precision. It updates the DOM and taking care only tweaks the things that needs to be tweaked. And in this case, the operation will be something like this. You say, hey, button.inner.text, I'm gonna add this as value 1. And this is the fundamental flow of React, the core loop. So when the component is mounted, when your server calls that, when the user calls your website, if this is built in React, it's gonna download that JavaScript. It's gonna download the HTML. It's gonna also download the CSS and the JavaScript. It's gonna parse that the HTML and the CSS into a DOM and a CSS object model, and also is going to run the JavaScript code, okay? And once that is done, it's gonna create is the render tree that indicate how the thing is gonna look like. This is what you need to know about this. Okay. Holy moly, bro. Makes a lot of sense. Makes a lot of sense. Makes a lot of sense. Okay, makes a lot of sense. Makes a lot of sense. Okay. Okay. So this is what is going to happen on the mount. So when we render the component for the first time, there is no previous snapshot to compare. So React will need to create those necessary DOM elements, which happen that on the initial render, exactly what happened is on the initial render, which happens on the initial render in the DOM, and then it's going to append all of these elements here, right? So once it append all of these elements, now you already have is the DOM structure. So far so good. However, when one of those components, one of these React functions, JavaScript functions, if one of them now trigger a state update, it's going to notify React to call this function that will produce, is going to call this function with this new value that is going to produce is this new description of the UI in a JSON object, right? But if this function contains more React element, more JavaScript functions, all right, it's going to continue to call all of them. Therefore, it's going to continue to create each one of those elements in this new snapshot, right? That when React compare those via the fancy algorithm called as the reconciliation through the diffing algorithm, when it reconciliate that, and once React has solved the puzzle, all right, now it's going to apply or commit is with a surgical precision. Exactly, it's gonna commit this change with a surgical precision to updates the DOMs that taking care only tweaks that thing that needs to be tweaked. So only thing that has changed is going to be applied into the DOM, right? So this is the operation might looks like this, and this is the core React loop, right? So you click in the boxes and to explore each one of them, and so on and so forth. This is quite interesting. It's like, how do you create this kind of stuff? Exactly. This is like a particularly box, grid column, all right, where you define is each one of them as a position, and this, and inside of this you say, hey, you know what? This will be a flex, all right, where the first element will be 10, and the x1 is this. This is the layout. Okay. So this is the layout. So this is the layout here. But this is the layout here. Display block. And here you put that position relative. Okay. And then you put all of these elements here. That's mind blowing. In fact, there is nothing here. In fact, there is none. So it's just it makes a lot of sense. This is an image. Okay, this is an SVG that already have all of this, and the only thing that you did is to say, hey, now let me add this. Okay, the layout here will be now relative. Okay, I'm not sure where you say it's like, hey, all of these elements, it'll be the next elements, it'll be the children element or the parent elements, right? So if you say, for example, absolute, I think it's affecting is the child element. So if this is relative, so what you're doing is like modifying this element here. So what you're doing is modifying this element relative to that to actually be rendered in that. Because look at this exactly. This bottom actually fits here. Holy hell. Exactly, because the normal way of rendering all of these elements is in this way. So it's interesting because this layout is affecting even the children. Hey, all of the children components here, all of the children HTML will gonna behave in this way. Oh my god. Okay, when you say top, it's gonna put it there and now provide some ratio here to actually make sure that it's going to be displayed in any dimensions. Holy moly, this is an SVG element, and then you have now all of these buttons here. Okay, okay, that was quite revealing here. So in this course, each model starts with a custom 3D illustration. You might remember seeing this complex machine from the initial lesson in this model. I create this illustration using 3D modeling software called Blender. In Blender, I can render my project to create a final image. This recording is speed up 150 times. It is not actually that quick. Mm-hmm. 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 The term render generally refers to this sort of things. We're taking some sort of unprocessed raw input and generate the final ready to use output. Even in web frameworks, this definition is pretty consistent. In Express, we take some raw things, okay, unprocessed raw things, and generate a final ready to use output. For example, request end when we render an HTML template. Okay, this is the terms of render. What the renders mean. Take some raw inputs, all right? Take unprocessed raw inputs, and then generating is a final ready to use output. Okay, it's like cooking. Okay, you can think of it like cooking. You can think of it like cooking. All right. Okay. Mm, GitHub Accelerator. Build rich content website with markup and React. That's good. That's great. But in any case, this is what render it means. It refers to. Okay. This is what rendering is refers to. In React, however, the term render means something slightly different. I think so much confusion in React's theme from this misunderstanding. Let's take a look at an example. Suppose I have the following component. Okay, so if I'm going to render this, which is take an unprocessed something and then generate a final ready to use output. So for example, you have here if h less than 18, and you say, hey, if I pass now a value here, age, and that age is less than 18, I'm going to give you this, right? In other words, we're going to create now this element in the GSX, all right? And therefore, pass you that. So our age limit component checks an age props and returns one of two paragraphs. Now let's suppose we render this component. We went up with the following before, after pair snapshot. So if the age is if the age is 16, it's gonna give you this. If the age is 17, it's gonna give you this. But if the age is now 18, it's gonna give you this. In both cases, it's less than 18, so we went up with the exact same UI. As a result, no DOM mutations happens at all. So when we talk about re-rendering a component, we aren't necessarily saying that anything will change in the DOM. We are saying that React is going to check if anything changed. If React spot a difference between snapshot, it will need to update the DOM, but it will be a precisely targeted minimal change. When React does change a part of the DOM, the browser will need to repaint it. A repaint is when the pixel on the screen are redrawn because a part of the DOM was mutated. This is done natively by the browser, and when the DOM is edited by JavaScript, whenever by React, Angular, jQuery, Vanilla, JS, and anything. To summarize, a re-render is a React process when it's figuring out what needs to change, aka reconciliation. The spot the difference games. Okay. And a render is different to a re-render. Okay. So if something has changed between the two snapshots, React will commit those changes by editing the DOM so that it matches the latest snapshot. And whenever a DOM node is edited, the browser will repaint the redrawing the relevant pixels so that the user see the correct UI. Not all re-renders require repaints. If nothing has changed between snapshot, React won't edit any DOM nodes and nothing will repaint. Exactly, not all re-renders require repaints, but the terminology here that is using between the rendering and the painting, and this is especially when you are, this is a term from the generation of image or videos, which is you take raw inputs of something, unprocessed raw input, and then you convert that into something that is ready to use, an output ready to use. So a good example of this is like cooking, right? You have all of this unprocessed stuff. You want to make an omelette, right? You have now eggs, milk, somewhat, and oats, a little bit of salt, pepper. I really love pepper. And you mix all of this in a bowl, all right? You add 3 eggs, 50 grams of oats, a little bit of milk, and salt and pepper. You mix all of that in that bowl, you shake it, and then you have that soup-like system. You already have a preheated oven or a pan, right? With a little bit of oil, olive oil, not that this because the smoke point of olive oil is not that high, so you set the heat low, and then you now once that pan is hot, you you pour that on the pan, right? And then you wait for that. 15 minutes has passed. You flip it over, and you got it, and now you get all of this. So you wait for 15 minutes more, and then you get that. So this is just to describe this unprocessed raw inputs into something that is ready to be into a ready to be used output. This is what renders mean. Okay. And because React is not going to re-rendering, or when it comes to React, when React re-rendering something, it's going to figuring out what needs to change, spot the difference, and through the reconciliation, right? If something has changed between these two snapshots, React will commit those changes by editing the DOM. And whenever those DOM is edited, the browser will repaint. Okay, and whenever those DOM is updated, the browser will repaint that, or will repaint, redrawing the relevant pixels so that the user see the correct UI. And not all re-renders require repaints, right? Because as you can see with this particular examples, if those descriptions of the UI, if those snapshots hasn't changed, well, React doesn't do anything here. So React doesn't manipulate the DOM, and therefore the DOM remains the same. The browser doesn't do anything. So the critical thing to understand is that when we talk about re-rendering, we are not saying we should throw away the current UI and rebuild everything from scratch. And React tries to keep the repainting to a minimum because repainting is slow. Instead of generating a bunch of new DOM node from scratch, which is a lot of painting, it's figuring out what's changed. How do we know? How do we know? How do we know? Yeah, how do we know? Of pegs and page. How do we know? That's a good question. That's a good question. So how do we know that painting, or that how do we know repaint, or how do we know repainting is slow? All right. This is a model 2. Enter a message. I would like to know if there is a source that describe why repainting in the browser is slow. You know what? That's a good question for Claw, bitches. That's a good question for Claw. Welcome, Claw. pressure cooker with timers. That's a good question for Claw, bro, fellas. Exactly. You are a browser, or you are a computer scientist. You are a graphic computer scientist, agent, expert, agent, ex, worldwide expert, agent to respond to few questions. When they respond to question, follow the following guidelines. Work through this, and there you go. Something like this, and this, and this, and this, right? So in my case, it's a very silly question. How do I know? I would like to know about that. Paul Irish Performance Talk. Chrome source documentations. Study shows repaints can consume 60 to 80% of the frame budget in complex UIs. Performs timeline demonstrate paint as a major bottleneck in 60 FPS application. Okay, please provide of your findings. The browser rendering pipeline architects. GPU versus CPU process difference. Layout calculation and paint operations. Composite layer and DOM manipulations. DNS lookup, parsing, exactly, and then building the DOM tree, preload, building the CSS object DOM tree, and then the JavaScript compilation. While the CSS is being parsed and the CSS objects created, other assets, including JavaScript files, are downloaded thanks to the preload scanner, and JavaScript is parsed, compiled, and interpreted. The scripts are parsed in abstract syntax tree. So browser engines take abstract syntax trees and pass them into a compiler, outputting bytecode. This is known as JavaScript compilation. Most of the code is interpreted on the main thread, but there is an exception such as code run in web browsers. Building accessibility tree. The browsers also build an accessibility tree that assisted devices used to parse and interpret a content accessibility object model. It is like a semantic version of the DOM. The browser updates the accessibility tree when the DOM is updated. The accessibility tree is not modifiable by assisted technology. Until the AOM is built, the content is not accessible to screen readers. And the render. Rendering step includes style, layout, and paint, and in some cases, composites. The CSS and the DOM tree created in the parsing step are combined into a render tree, which is then used to compute the layout. Which is then used to compute the layout on every visible element, which is then paying on the screen. In some cases, content can be promoted on its own layer and composite, improving performance by painting portion of the screen on the GPU instead of the CPU, freeing up the main thread. Style. The third step is in the critical rendering path is combining the DOM and the CSS object model. The third step is in the critical rendering path is combining the DOM and the CSS object model into a render tree. The computed style tree or render tree construction start with the DOM, with the root of the DOM tree traversing each visible node. Elements that aren't going to be displayed like head elements in its children, and any node with display node, such as script display node, you will find in user agent style sheet are not included in the render tree, as they will not appear in the rendering output. Nodes with visibility hidden apply are included in the render tree, as they do take up space, and we have no giving any directive to override the user's default. The script node in our code example above will not be included in the render tree. Each visible node has its own CSS object model. Rules applies to it. The render tree holds all the visible nodes with the content and computed style. The render tree holds all the visible nodes with content and computed style, matching up all the relevant styles to every visible node in the DOM tree, and determine based on the CSS cascade what the computed styles are for each node. The layout. The fourth step is the critical rendering path is running the layout on the render tree to compute the geometry of each node. It's on the layout that is going to compute the geometry of each node exactly. So layout is the process by which the dimensions and location of all of these nodes is rendered in the render tree are determined, plus the determination of the size and position of each object on the page. Reflow is any subsequent size of position determination of any part of the page or the entire document. And reflow is the subsequent size and portion and position determination of any part of the page or the entire document. But the layout is a process in which the dimensions and location of all of the nodes in the render tree are determined. Here I want you to calculate is the dimension of this object and the position of this. Plus the determination of the size and position of each object on the page. And reflow is any subsequent size and position determination or any part of the page or the entire document. Once the render tree is built, layout commences. The render tree identifies which node are displayed even if it is invisible along with their computed style, but not the dimensions or location of each node. To determine the exact size of the position of each node, the browser starts at the root and render of the render tree and traverse it. That's one of the reasons why you need to understand at least how this French those things do. The FCS, breadth first search. On the web page, almost everything is a box. Exactly. On the web page, almost everything is a box. Different devices and different desktop preference means an unlimited number of different viewport sizes. In this phase, taking this viewport size into consideration, the browser determines what the size of all the different boxes, depending of the viewport, what is the size of all the different boxes are going to be on the screen, and taking the size of the viewport and its base. Layout generally start with the body. Lay out all the size of the body descendants with each element's box model property. Providing placeholder space for replace elements, it doesn't know the dimension of such as our image. The first time the size and position of each node is determined, it is called layout. The first time the size and its position of each node is determined is the layout. Subsequent recalculation of the layout are called reflows. In our example, suppose the initial layout occurred before the image is returned. Since we didn't declare the dimension of our image, There will be a reflow once the image dimensions are known, and then you have now the paint. The last step in the critical rendering path is painting the individual nodes to the screen, the first occurring of which is called the first meaningful paint. Okay, the first meaningful paint, but I don't. Is deprecated in Lighthouse 6.0. Moving forward, considering using the large contentful paint API. Okay. In the painting of rasterization phase, which is the process of transforming it into pixels on the screen, the browser converts each box calculated in the layout phase to actual, exactly. Each one of those calculated layout, it'll be now converting into actual pixels on the screen. Painting involves drawing every visual part of the elements on the screen. Every visual part of the elements on the screen. So each refresh is doing that. Shadow and replace elements like button and image. The browser needs to do this super quickly to ensure smooth scrolling and animation. Everything occupying the main thread, including calculating style along with reflow and paint, must take the browser less than 16 milliseconds to accomplish. At 2, the iPad has over 3 million of pixels, over 3 million of pixels to be painted on the screen. Holy shit, that is a lot of pixels that has to be painted very quickly. To ensure repainting can be done even faster than the initial painting, the drawing to the screen is generally broken into several layers. If this occurs, decompositing is necessary. And painting can be break the elements in the layout tree into layers. The painting can be break the element into layer 3 into layers. Promoting content into layers of the GPU instead of the main thread on the CPU. Improve painting and repainting performance. There are specific properties and elements that instantiated a layer. Okay, so there are specific properties and elements that instantiate a layer, including is the video and canvas, and any element which has CSS property of opacity, so it has been promoted to be part of the GPU layer. A 3D transform will change and few others. This node will be painted onto their own layer along with their descendants, unless a descendants necessitate its own layer for one or more or above reason. Layers do improve performance but are expensive when it comes to memory management, so should not be overused as part of the web performance optimization strategy. And the compositing. So anytime that you now use any of this particularly HTML tag or CSS, you are promoting, aka creating is a layer into this GPU. As the page continues to load assets, reflow can happen. And recall our example image that arrived late. A reflow spark, a repaint, and recompose it. How we define the dimension of our image? A reflow spark, a repaints, and recompose it. Because reflow is what happened when the layout is calculated. Okay? So subsequent recalculation of the layers are called reflow. And the reflow spark a repaint and then recompose it. Have we defined the dimensions of our image? No reflow will have been necessary, and only the layer that needs to be repainted will be repainted, and composite is necessary. But we didn't include the image dimension. When the image is obtained from the server, the rendering process goes back into the layout step and restart from there. Once the main thread is done painting the page, you will think we will be all set, and that isn't necessarily the case. If the load include JavaScript that was correctly deferred and only executing after the onload events fires, the main thread might be busy and not always for scrolling, touch, or other interactions. Time to interactivity is the measurement of how long it took from the first request, which leads to the DNS lookup and the TCP connection, the handshake, to when the page is interactive. Holy fuck. Time to interactive. Interactive being the point in time after the first contentful pane when the page responds to user interaction within 50 milliseconds. If the main thread is occupied parsing, compiling, and executing JavaScript, is not available and therefore not able to respond to user interactions in a timely less than 50 millisecond fashion. In our example, maybe the image load quickly, but perhaps the another script.js file was 2 megabytes and our user network connection was slow. In this case, the user will see the page super quickly but wouldn't be able to scroll without jank until the script was downloaded, parsed, and executed. And this is not a good experience. Avoid occupying the main thread and demonstrate it in these web tests. But that's quite interesting what's going on here. Okay. So when you mutate something, okay, the browser detects that DOM mutation and then now pass into the reflow phase, which is the way how it's going to calculate is the layout. And this layout phase is when the position and the geometry of the elements are computed. And once it has this information, then it's going to now paint that. So transform that. So now it has the informations that require that this will be the dimension and this will be the positions. So now it's going to paint those images, or the rasterization phase. And the rasterization phase is this. It already knows which pixel is going to paint this box, or this another box, or this another box. But it's because it's on the layout that has this information from that. And if you use, for example, is certain HTML elements like video, canvas, or CSS property like opacity and 3D transform, 3D transforms, you are now promoting content into layers on the GPU. So you are telling now, hey, I want instead of using the CPU to compute that, so to show elements on the screen, to render elements, to paint elements on the screen. I want you to use now the GPU for that. And then it's going to create now these layers here. Layers do improve performance, but are expensive when it comes to memory management. So you should not overuse as part of a web performance optimization tech strategies. Okay, I think that'll be all for this video. Take care.